Welcome back, guys. This is going to be the fourth part of our design pattern series. We in last part of our tutorial we wrote a singleton object. Um, you know, using singleton with double lock checking. So basically, that's what we wrote. But this implementation is little extra involved. It's doing a lot of extra work. They in Java there we can write very simple implementation of it, which could and by avoiding a lot of extra null checking and of course extra synchronization checking. So we can implement one more person after singleton. Let's go ahead and write. I'm going to go ahead and create a new class. Let's go ahead and create a new Java class here. I'm going to give it, call it log free and threads, log free, thread safe, singleton. Okay, singleton object. All right. Just like before, for any singleton, of course, we need to have a private constructor. So that's the very first thing we can do. Okay, we don't have anything here in the right now in the private constructor, but in our real life application, of course, we might have huge amount of other private field that perhaps we would be initializing in our private constructor. But this private constructor guarantees that the user will not be able to create instance of this object from outside. All right, the next thing, next thing we have to do with this pattern is we can create a private static I'm going to call this underscore instance here, and then right away I'm going to create a new instance of it and assign to the field. Okay, that's the first thing. That's what we have to do in this pattern. We basically create a field called underscore instance, and we initialize the, and right away we create an instance of this object and assign to this field. All right, now of course we need to some method to expose that to private world. So we're going to say public static synchronize. God, I cannot type synchronize here. All right. Static synchronize is of course this guy going to return this instance here. And as you might have guessed, this implementation of this guy is very simple. We're just going to return itself. We're just going to return log free singleton dot in the instance. Why it is complaining? So I didn't give a name of the method, right? Get instance. Sorry for that, guys. I was wondering. This is just the return type, and I forgot the name of the method here. All right, so very simple. This pattern, as usual in singleton, our constructor is private, and we have this very private field here with our instance, and we just as soon as this class is called, this field is initialized and it is returned here. And of course, we will have large amount of instance method in here. Just for as to follow our example, we have been using let's say a void method. I'm just going to say greet. That's what we've been using for all our example. And I'm just going to say, all right. I'm just going to, of course, you might have use amount of method with your one implementation based on your business rule. But in this case, I'm just going to print out hello from lock-free thread-safe synchronization. Okay, so this name is very, very useful. So because here we just create our instance right away into the field. That means it is also it's a thread safe singleton, and then lock free means we don't have to do well, like in the previous example, we don't have to check for null and all those things because we already initialize into our field. All right, let's see. We can use this one is, as you might have guessed, this one is very, very simple compared to the other pattern that we use that required double checking and synchronization and avoidance of the thread safety, all those kind of thing. But by using this pattern in Java, it's a lot easier. At the same time, it is both thread safe, and it also it doesn't also avoids locking mechanism that I've been talking about. And that additional checking that we had to do for our previous one is also not really need to do. All right, that as you guys as you can see, this implementation is very, very simple and not that many line of code here. All right, let's go ahead and save this one. We can write a little method to test this. Let me create new class here. And I'm going to follow the same path that, I'm going to call it as a name as test. Well, I could have added new main method here, but write it by hand. That's okay. All right. We have our main method, and then I'm just going to copy the code from that previous test that I wrote, that we have written for the other one. So basically, I'm going to create a bunch of thread here. Log free singleton test. So I want to spawn, like, I don't know, maybe, I don't know what happens if I spawn 200 different threads. And instead of calling, so I'm going to call log free singleton. Log free thread safe singleton. And I need to get an instance of this, the same pattern, and then at the end I'm going to call this grid method. So we have this, just like a previous example, we have this anonymous thread with this run method, and once we set it up, our thread, we just finally call the start method. That would start the thread. Oops, I don't mean to touch it there. All right, let's go save everything, and then I'm going to close others, only this method. I'm going to go ahead and run. So or we can put a breakpoint here into our private fields. Well, this one is pretty simple, like, so even I'm not going to put a breakpoint. I'm just go ahead and straight run this method. So you will see the simple output, and it basically spawn the thread, and then all right, run this method, run this code. Pretty cool. It was able to spawn that many thread and basically said, okay, from which thread the message was coming out from. So of course, as you can see, the threads are not in sequential order. They are like, all right. So anyway, this is